Okay, so here we are in home stretch. Going to start the discussion of geologic time and specifically the geologic time scale and some of the features that are associated with that. And what things you want to remember. Where the names come from, we already kind of touched on that and so forth, but just kind of give you an overview of this. So here is a view of the geologic time scale. And, one thing you may notice right away is there's kind of two different depictions of it here. One is kind of looking at some very broad timelines, and you may also notice that at the top of this little these two little depictions, there are different names for the different slices of geologic time that are depicted in each one of these. Excuse me. In the first case, we have eons, which are the largest segments of geologic time. There's very few of them. There's the Precambrian, which has some subeons here, and the Phanerozoic. Okay, the Precambrian covers everything up till about 500 and I think that says 40 or something, 550. That number is kind of changing with time as we're getting better at dating things. But let's say 550 million years ago. So we go from, well, first of all, what was the age of the Earth? About 4.5 to 4.6 billion. Most of that, almost 4 billion years of it, is in this Precambrian time slice. Okay. Then we get into the Phanerozoic time frame, and we're way up here at the top of the Cenozoic. Okay, this which is the next column here, the eras, where we're starting to now divide geologic time into smaller slices. So we make up a very small part of it, but we'll look at that here in a moment as well. Some of the peculiarities, if you will, or the specifics about these major two time units. Back in Precambrian time, well, we don't know a lot about it because it's when things were, very ancient. We do know some, we just don't know as much as we do about things that happened in the Phanerozoic. One, because a lot of the evidence isn't there anymore. It's been removed over time as the Earth system has changed. But we do know some things, like we believe that back here in the Hadean period, that, that was pretty much time when things were in upheaval. We're still being bombarded very frequently by, asteroids and other things. And there was a time frame about 4 billion years ago, by some people's estimations, that the Earth may have been almost essentially totally molten. Okay, but when we get up to 3 billion years, the Earth has kind of taken on form. During the Archean, by that time oceans have formed, plate tectonics kicks into gear, and other things set the stage. As we come into the Proterozoic, the last period of the Precambrian, life is definitely formed by that time. Actually, it formed back in the Archean, probably, from what we can tell. But it's all pretty simple, single cell, organisms at this point in time, nothing overly complex. When we get into the Phanerozoic, the diversity of life expands dramatically. So that's one of the things that happens in the Phanerozoic. Okay. When we get down to the eras, of course, we have the early, lates, and middles of all these early things. Again, we don't understand. We're still learning a lot about that based on the little evidence that's left behind. When we get into the Phanerozoic, we have the Paleozoic, old life. Mesozoic is middle life, and Cenozoic is recent life. And we know a lot more about this because there's a lot more of those rocks involved. So if we look up, over here at the right-hand depiction of this, we can go beyond the broadest slices of geologic time with eons into eras. We can actually then start to subdivide eras into periods because we know more about the periods and what's going on there based on the rocks that are present. And when we get into the closest time frame up here in the Cenozoic, we can further break it down from periods into epochs. Okay, so as we work through the Phanerozoic, back in the early Paleozoic, okay, the old life sequence, a lot of fish and so forth. Much of the Earth system was very marine oriented, so that what was going on there. By the latter part of the Paleozoic, Pangea has formed. And land plants seem to start becoming dominant. And then as we go from the Paleozoic into the Mesozoic, we make another transition. The dinosaurs come into play. Okay? As we leave the Mesozoic and go into the Cenozoic, the dinosaurs are been extinct or were extincted, went through an extinction event, and the mammals took over. So since that time, the mammals have been at role here. Again, the closer we get to the present, the more rocks, geologic units we have available, the more we are able to go in and interpret and understand what's going on there, so we have these smaller slices. And again, here's another look at how the geologic time scale is structured. Eras are, eons are the greatest slices of geologic time. The first subdivision of an eon, broad subdivision of the eras. The eras of the Phanerozoic include the Paleozoic, which is ancient life, Mesozoic, which is middle life, Cenozoic, which is recent life. As we get into this Phanerozoic period, much more information available. Life is much more diverse, so we subdivide the eras into periods. And as we get up into the closest time frame, the last 65 million years or so, we know a lot more about that. There are a lot more rock units available, a lot more fossils available, so we're actually able to divide those things into even smaller units called epochs. So, where do the names come from? Well, as I mentioned earlier, it comes from certain places in the Earth system, pretty much. Oftentimes, where those rocks were first studied. The Cambrian period here, taken from the Roman name for Wales, Cambria. Okay, so where rocks were first studied there. Where the Ordovician and Silurian come from, where Devonian comes from, Devonshire County in England, where a lot of those rocks are found. Mississippi River Valley, okay, where a lot of those rocks were exposed and therefore studied. The state of Pennsylvania and Pennsylvanian. Permian comes from Perm, Russia. Cretaceous comes from the Latin word chalk. There's a lot of chalk that were formed in the Cretaceous period. The White Cliffs of Dover, the Niobrara chalk here in the United States. If you ever get out to western Kansas, pretty much western Kansas, to a place called Monument Rocks, that's an exposure of one of the members of the Niobrara chalk when those rocks were at play. So that's where these names typically came from. Okay, so just kind of an overview of Earth history, what's gone on during those periods. You can read more about it in the text, but just to kind of wrap up here, a couple other things I wanted to point out. Again, the broadest time slices of geologic time, we go from eons to eras, eras to periods, periods to epochs, and you'll notice that we're getting closer and closer to present time. More rocks are present, life more diverse, more fossils present. We're able to interpret more, so we understand more about that, and we're able to make those subdivisions more cleanly. At least at this level, we'll leave it at that. Okay, here's a geologic cross-section. You need to go and interpret it. The answer to this slide set is at the end of this sequence. But before you actually go and visit this, because I'm actually going to end the video basically down there, you should stop the video here and go in and do your interpretation. I'll tell you some things you want to be careful of what's going down in this section of the diagram, as well as what's going on up here. Okay. There's also another absolute dating problem. Here I give you an example of an igneous rock that has certain minerals in it, tell you how many daughter isotopes are present, atoms of the daughter isotope, how many parent atoms atoms of the parent isotope are present, tell you what its half-life period is. What you need to go in is figure out how to go and approach this. Remember, the number of atoms within the system at any given point in time is always constant. So at time 0, how many were there? I'll let you figure that out. Okay, and then just kind of some slides that deal with the different types of unconformities, angular unconformities, nonconformities, and disconformities. Again, there's nonconformities and disconformities. You can stop the slide set and read those, so I'm not going to spend a whole lot of time on those. And then again, you don't want to go to these next two slides until you've gone and done the interpretation of the two problems before it. But there's the interpretation of the geologic cross-section. There's your approach for solving the absolute dating problem. That brings us to the end of this slide presentation. We'll talk to you all again soon.